Hi guys, welcome to a tutorial about Git and GitHub for absolute beginners. So let's begin with why do you even want to use Git or why might it be interesting? Let's have a look at a small project that I made a while back. It is a snake versus blocks game and it has a lot of Java files and a lot of code, so you could say it has about a few thousand lines of code. Now, if you look at this game, this is what it does. There's a snake and you have to dodge the blocks and gain some points and collect tokens and so on. All right. So let's say I have a friend of mine who is helping me out with this project and we're working together. Now, I want him to make some changes. I want him to, let's say, add a different music file here, and while he's at it, he also does a few improvements. He changes the speed of the snake and he also adds some new functionality. Now, how do I collaborate with him? How do I send him the source code and how do I ask him to give me the new changes and so on? So let's say I zip all these files up and mail it to him. He makes some changes here. He adds some new sound and he says a new sound here, and he changes the speed to 30 and he makes a few other changes, saves it and sends me back the source code. Now what happens is I do not know what changes did he make. I knew what changes was he supposed to make in terms of functionality, but in terms of code I am not sure, and I would like to look at it. I want to see how the change is implemented so that I can do a similar thing sometime in the future. Now, you could say I could just ask him that what were the changes, and he'd open the same files and tell me that, okay, see line number 121, I made a change here, I made a change here, but he might not even remember what changes did he make after a while, right? So, how do you resolve this? Let's say I created a copy before I sent him the source code and a copy after he made the changes. But even then, even if I have two copies of the source code, it is very difficult and very cumbersome to open both the files side by side and see what changes were made. You might even miss out on some changes. And let's say, so how do you do this? And let's say I were to make some other changes sometime in the future, and by mistake, I removed this. Oops, now what? It is lost, right? For a normal project, for if you accidentally were to delete something or you accidentally were to add something else, or you're working on some feature and it stops your project from building, it stops your program functionality, how do you go back? You might have a backup which was of yesterday, but all the changes that you did today were lost if you were to continue from that point, right? So it is not an intuitive problem. It is not a problem that you can easily solve, but we have Git. Git makes it extremely easy for us to take advantage of all these scenarios, to work very efficiently in all these use cases. So I happen to use Git in this project, and this was not just there, and I did not send people by the source code by email, but we rather used Git. Now, how does it help me? Well, if you see, I have two versions of my code here. One is with Git and one is without Git. With Git, just adds about 7 MB of content to my project. But what it helps me with is that I have around 150 checkpoints in my program. I can go back to any of those checkpoints. At any checkpoint, I can see what were the changes made at that time. And I have the flexibility to, I have the rather power to experiment. I can make some changes, and even if they were to go wrong, I'll have the ability to roll back to some previous version which was working perfectly fine. So that is what this 7.5 MB of data gives me. Just that small increment in size, and it gives me a vast set of capabilities, including a way to collaborate with others. Now, If you were to do this without Git, if you were to, let's say, just make copies at every point in your code, so given this one given this 14 MB of code, and let's say you were to make a copy say 150 times, so that would have been 2000 MB of code, which is approximately 2 GB. And right now I have 20 MB and I can do the same thing. Now, how is this happening? What Git does internally is to just store the differences. So if you were to make copies of the code, you would be uselessly copying a lot of lines which were exactly the same. Even if you were to make a change in one single line and you were to add a checkpoint there, you will have to copy the whole source code again. All of the 10 MB, all of the thousands of lines of code again. But what Git does is just store that one single line that, okay, hey, at this point, this thing was changed. And that's how wonderful it is, and that's why you should learn it. You should learn it so that it gives you the power to experiment, to collaborate, and to work more efficiently, to not care about making a lot of backups and backups, or worrying about, what if this goes wrong, or even the opportunity to work on two different features at the same time. That the last part, working on two different features at the same time, is done using a concept called branches, and we will not be able to cover that in this tutorial, but all the other things, all the other awesomeness that Git offers, we will try to look at in this. So well, let's proceed. What is GitHub? Now, GitHub, well, let's say I have this project and I were to upload it on Google Drive. What it would show me will be just this. It would just show me what the current version is, and that's all. If I were to make versions, I'd have to make folders and add all the versions in there. On the other hand, if I have this, it just has this .git folder which is generally hidden, so if I hide the hidden folders, you would not be able to see it. But that .git folder is the magic behind all what's happening here. Now, project, a little bit of terminology here. Project is called a repository in terms of Git. So this folder, I'd call this as a repository. This project, I'll call this as a repository. GitHub offers me a smart way to host, or to, store this repository remotely, to store this on the cloud or their servers and access it between me, my collaborators, or even publicly for everyone to see, use, and experiment with. Now, GitHub offers you to, look at all those versions and to see more graphically in a UI that you can understand very intuitively. So that is what is GitHub. There are also some other alternatives like GitLab, Bitbucket, and so on. But in this tutorial, we're going to look at Git along with GitHub. So let's start with Git. Now, do note, Git by itself does not ever need GitHub. GitHub is just like hosting your code somewhere, but Git is a complete thing in itself, which you can use without ever hosting your code somewhere else. But if you want to collaborate, it's going to be much, much, much easier if you host it on a remote, like say GitHub. Sorry. So the first step is that you want to install Git. Now, for this, you should just go to your command line and say you're on Linux, you type this command, Fedora this command, and for macOS users, I'd recommend that you install brew, and after that it's a simple command called brew install git. Also, there are some other instructions for Windows which you can have a look at going at this website. This is the official website for Git, and you will have a download link right over here which you can use. So well, what do you do after that? Once you install Git, whenever you make a repository and whenever you try making changes and so on, it's going to ask you what is your name and what is your email and so on. So it is recommended that after you install Git, you just configure your global settings that, okay, hey, my name is this, my email is this, and why do you want to set the editor? Well, the default editor for Git is Vim, and it has some like people face some difficulties in saving files in Vim and exiting it and so on. So if you have a look at this, Vim is this. So it is hard for you to intuitively understand this. You cannot write code here unless you type I, and after you type it, you have to go back, you have to press escape and then a particular sequence. So it's a little bit difficult. On the other hand, if you use Nano, it's going to be simpler because it's going to help you in, even with some commands at the bottom. So if I say that I want to save this, I can just type Control plus X to exit, yes for save, enter, and that's all. So it might be a nice idea for you to do a git config global code editor nano. Do note this git is on the second line, not here. So this is one command, this is the next command, and this is the next command. Well, what is the next step? Given that in this tutorial we're going to be using GitHub, I recommend you to go on their official website and sign up for it, because you will need an account to create a repository and host your code online. The third step would be to optionally, note optionally is very important here. You should do this only if you're very comfortable with experimenting, because it might not be very intuitive if you're an absolute beginner. What this helps you with is, suppose you want to push your code and do any changes to your remote from your local, you will have to each time give your GitHub username and password. SSH is a way to securely log in without a password. What it basically does is generates a public-private key pair, and there's a type of authentication which goes on in the background. This is a very nice guide by GitHub themselves for how to configure it. It would take about 10 to 15 minutes to go on along with this, but you can choose to do this later on. It comes in extremely handy when you have to work a lot with Git. You have to push a lot of commits and you do not want to write your username and password each time. So you might want to have a look at this maybe later on. The next step, well, let's get started. Let's see, how do we create a repository? How do we work on a project? So let's say I create a new project saying my first project. I open a terminal window and I go to this path where the project is, desktop, git my first project. This can be anywhere in your system, doesn't matter. You just have to go inside that folder from your terminal. Once you do that, yes, also note that we can do this even on a project which already has files. So it's not necessary that this is empty at this moment. This can have all of your project, and let's say you want to add git to your project starting now, then you can surely do this. So once you're inside this, you type git init. What this does is adds the magic of Git to this folder. It makes it a Git repository and it helps you to keep track of it. And if I show the hidden files, you will see it makes the .git folder. That is where all the magic lies. That's where all the files for versioning reside. So what is the next step? Well, let's learn, or let's look at what are commits. So earlier I used a normal term called checkpoints. Now, more formally, it's called commits in Git. What that means is that, let's say you're working on a file and you want to say that, hey Git, look, I was working on adding a new token in my game and I'm done doing it. I want you to create a point in my history saying that, okay, these all changes were made and these changes were made to add a new token called star. Now, to do that, all this is bundled as a commit. So you can have an untracked file at first. So if let's say I create any file here. Let's create a normal file saying hello.py. Yeah. now I say hi there. So my file is added. Now Git does not know anything about this file. So at the very beginning, it's an untracked file. What you can do is, suppose you want to commit it, and it might be the case that you don't have just this file, but you have another file called test.py, and that says yeah. So I have two files in my project now. One is called hello.py and the other is test.py. Now I want to make a commit, but I don't want to make a commit with both of these files. I want to just add hello.py in one commit and maybe test.py in the other commit, or for now I just want to keep it without making any commits or without putting it in the Git history as such. So at this moment, these two are untracked. Now to make a commit, if you can imagine, you cannot just say git commit and it would automatically figure out what you want, right? You have to specify what all files do you want in that particular commit. So what you do is you put them on a stage. A stage is like, you can imagine as a, you know, just like a performance, that before the performance you put everything on the stage, you put the props, you put the actors on the stage, and then the performance starts. So similarly, to make a commit, before you actually make the commit and give it a message, you put the relevant things on the stage. So when you have an untracked file, you add the file and it gets staged. Once the file is staged, you can, add all the other files, remove files, whatever you want. Once you're done playing around with the stage and putting all the required files in the stage, you can make a commit. Making the commit would add it to the history of Git and mark those files as unmodified. What unmodified means is that presently Git knows about it and Git has the history about it, and there has been no change after that. So if I were to make a change in test.py, Git would not know about it because it did not save it in its history. But if I make a commit and if I tell Git, say, here's this file, hello.py, and I want you to keep a track of it. So if I change a file after that, it's gonna mark that file and those changes as modified. And then again, I can add them on the stage, make a commit or not, and so on. So that's the basic idea of it. I know it might be a little it might seem a little complicated right now, but we are going to do all of these steps right in the terminal and right in front of you, so it's going to be much easier. So let's see. Now let me introduce you to your first git command. It's called git status. What that helps you with is Git is gonna tell you that, this is the current status, or this is the current point of your project. So if I type git status, it's gonna say on branch master. Let's ignore this for now. It says that there are no commits yet. I do not have any commits, and there are two untracked files called hello.py and test.py. It also gives me a hint. So Git has this amazing feature of giving you hints. So it tells you that, okay, you can use this command to do this, you can use that command to do this. So that's going to come in handy sometime. It says that there are two untracked files, and you can use the command git add and the file name to include them onto the stage. So it says to in what will be committed, and that means that it will be on the stage. So now let's say I want to add hello.py to the stage, and I do a git status again. It says that these are the changes to be committed and this is an untracked file. Perfect, that's what I wanted, right? So this is this command here. If you use git add minus minus all, it's going to add all the untracked files and all the modified files onto the stage. The next command is git commit minus m in your message. So if I were to make a commit out of this, I could say this is my very first commit, and now, wow, you've just made your first commit. And I recommend that you try it all these steps yourself as well. Maybe after the video, maybe along with, as you wish. But you will learn Git only when you try it. It is extremely, extremely useful to try these out yourself, because that's when you learn the most. And I'd also recommend that do not be afraid of it. When you make mistakes, that's when you learn the most. So it might be a good idea to in the beginning make a copy of your project sometimes, in case you mess things up and get and you're not able to remember how to solve it. But solving it is the part when you would learn the most. Take the help of Google, look on things online on how to roll back to a previous version and so on, and you'll learn a lot. So let's continue. You have just made your first commit, and if I do a git status again, what is it gonna tell me? It's gonna say that I'm on branch master, there's one untracked file, and it did not say anything about hello.py. Why? Because it has been added and Git knows about it, and there has been no changes after that. So let's say I were to change this. I were to say hello world. And if I were to do a git status again, it would say that this file has been modified. Now, how did it know that it has been modified? Is because you had added it to the git tracking and you had made a comment about it. So it knows that, okay, this file, I am supposed to, take versioning of this and remember things about this. On the other hand, if you were to make some changes to test.py, Git would never know about it because it was untracked. So Git does not have any history or any remembrance of the file or its contents. So if you want to add test.py as well, you can just do that like this, and you can add both of the files, make a commit, and so on. So once you do that, let's say I make a couple of more commits. I'd say adding the test file to git versioning. All right. Do remember, before you make a commit, you have to add the file to the stage. Once you do that, all right. Once you have this and you do a git status, it's going to say that I'm on branch master, there's nothing to commit, and everything's clean. Now, how do I look at all the commits I made or all the things I did? There's a nice little command there called git log. What is that going to do? That's going to show you all the commits that you've made till date. You can scroll down if it does not fit your screen. Each commit has a hash, which is the special string representing that commit, and there's author name and the email address, just the same one which you configured it earlier. There's a timestamp to your commit and the commit message. Commit message is essential, and every commit must have a message along with it. So well, that's all for the local using of Git. Now there are a few more commands which you might want to have a look at, which one of which is checkout. So if you want to go at this particular commit in the history, what you simply do is git checkout and the commit message. So once I do that, I have a look here. These files are as they were at that point of time. This is hi there, and this is let's begin testing. Unlike what was after this commit, so if I go back to where I was, which was at the master, it would revert the files to the way they were at the end. So that is the beauty of Git. You can roll back, you can make changes, and you can also make branches, which is to work on two different aspects simultaneously. The same as creating a copy of your project and then working on two different aspects and then combining it. So something like that, but without ever creating a whole copy of your project. So I hope this is settling in your mind, and if not, I recommend you to take a break at this time and look back at all the commands that we did and try and execute them for yourself. The next thing which we are going to do is to host your repository. We're going to use GitHub to add a remote and to put this online. Now, it can be either way. It can be a private repository or a public repository, as you wish. So you go onto GitHub and you click here for a new repository. Once you do that, you have to specify a name for the repository, which let's say is my first project. I make it private for now, and it gives me an option to initialize it with a README file. What a README file is basically a small text file. It's often called as a markdown file because that's how so in Word it might have been very easy for you to bold some text and underline and so on. Markdown is a basic form of it, so it's like a normal text file in which you can use some sequence of characters to make some headings or make some text bold and so on. So much simpler than Word, but basically a text file. So it says that you want to create this README file because that's what's going to show up on your main project page. So something like this. It's going to preview your README file. So it gives me the opportunity to do that, and it also asks me if I want to add a git ignore or a license. We'll get to, you can read about it more later on. For now, we just create a new blank repository without these options. Now, GitHub gives you a few options. It says that, okay, hey, you might want to create a new repository or you want to push an existing, and these are the commands which you want to use for the same. Now, let's have a look at this first. It says if you want to create a new repository, what you would do is you could possibly create a README file. This would just basically create a text file with this as the only content in it. The next thing it says is that in that folder you use the command git init to add git tracking. You do a git add and the file name to add it on the stage. You make a commit. Let's say that the commit name is first commit message is first commit, and then you use these two lines. These are the same as pushing an existing repository from command line. So this is what we're going to do right now. Now let's have a look at the first command and what it means. It says that, hey, you were the local repository, you were there by yourself, you never knew what is the world around you, and you never had some place where you were hosted at. So look, this is the link of my remote on where I want you to reside. So I say let remote add origin. So basically I'm naming this place as origin and adding this link. And the next thing, so now if you do a git remote -v, it's going to tell you the link of the origin. So it's going to just say that, okay, you configured this local repository to link with the repository at this address, and git push -u origin master means that I want all the commits which I have locally which are not on the server to be uploaded online. Once that's done, if you refresh this page, you will see all your project there. Now let's say if you were to do that with the HTTPS, if you did not configure SSH, at this point it will ask you for your username and password. If you have a look at the project, you can go on the commits and see what the commits were. If you go at any commit, it will also show you all the changes that were made. So it highlights that hi there was removed and hello world was added instead. If you have a look at another commit, it would say that one file was added, which was test.py, and this was the only line that was added to that project. Simple, right? So that's the UI part. Now, suppose you collaborate with someone. Suppose you go to your settings, in the collaborators, you add a username here. You add your friend's username here and you add him as a collaborator. Now he might also push some changes online. So if your repository has some new changes which your local repository does not, which might be often the case, then you use this command called git pull. Now what this would do is take the changes from the remote and add it to your local repository. So this might come in useful a lot of times. Now, what is the git clone command? It is, let's say, I have this project and I want to make, like, a friend of mine wants to make a new copy of it. Even you can open this project as it's a public repository. You can just go on this link and you will see all of it here. You'll see all of my 151 commits or checkpoints and what was done. So let's say that properly removing the objects on game over, you want to see what changes were made at this point of time, and you will see all the changes. Pretty simple, right? You want to see how did I remove it? You have the exact lines that I removed and added for it. And you know what? Git can also be used in other contexts. Git can be used to create a website, to version a website. This blog, for example, I've written this using it. It has the tracking there, and you can view the source code online. So that is how GitHub works, the basic idea of it. What you might want to have a look at for further reading is these are a few commands which I personally like. You might have a look and see what they are. You can read about them more online. There are a few links at the end which you could use. Also, there's a GitHub Students Pack. If you were a student right now, you might want to sign up for this. They give a lot of freebies. There are a lot of DigitalOcean credits, GitHub Pro account, and so on. So you might want to have a look at this. And the other resources that you should look at would be Atlassian. There are some cheat sheets. There's a Git by the founders, ProGit. There's a book by the founders called ProGit, which will be extremely insightful. And then there's also a simple guide. So I encourage you to check those resources out if you want to read further about this. There's a small write-up that I've written for gitignore. Basically, gitignore helps you in, telling it that ignore some files. Say you have Python, you have some extra PYC files and you don't want Git to remember it or keep telling you that I don't know about this, then you use gitignore. So that's all for now. I hope you enjoyed it and I hope you use Git as much as possible.